Welcome to this video in a series of videos on refraction through lens. In this video, we're going to look into the rules of the ray diagrams before we understand how we're going to use these ray diagrams to predict what happens when you see an object through lens. All right, so the first one is, whenever you draw a ray diagram, it's always important that you use a scale and pencil. So let's use that to draw our convex lens and concave lens. All right, so first thing is, it's always a good idea to draw your principal axis. So let's draw the principal axis, and let's also mark the optical center, right? So the optical center would be somewhere here, let's say. So this is my optical center, and mark about approximately at a distance of about, I don't know, a comfortable distance. In this case, let's take one unit, and here 2 units. So let's mark a position here and an equal position, 2 points with equal distance. So here also let's do the same. Let's mark these 2 points, 1 and 2. Now these are equidistant points. So we're going to call them as we're going to mark them as, this is going to be our F, this is going to be our 2F, this is going to be our F, and this is going to be our 2F. Now once we do that, let's draw the center of our lens, which is here. So let's draw the center of our lens. So this is our center, and let's mark 2 points which are equidistant in the top and in the bottom, right? So this is 1 point, and this is the equidistant point, the top and bottom, right? All right, so once we do that, we can use this to draw our lens as thin as possible. So this is the step 1 of our drawing ray diagrams. So first one is you draw the principal axis, you mark your focus 2F, approximately same distance, and then we are ready to draw our ray diagrams. So let's see the first one. Ray incident to an optical center. So any ray that goes through the optical center, and this is something you would have, by the previous videos you have seen, that these rays, any ray that goes through the optical center would go undeviated, right? So you saw it in action, that any ray that goes through the optical center would go undeviated. So this is our rule number 1. So let me mark this as our rule number 1, and this is our first point. The second point would be a ray parallel to the principal axis. So let's draw a ray parallel to the principal axis. This is the second point, ray parallel to principal axis. So I hope you're drawing all these with me. So if there is a ray that's parallel to the principal axis, that ray will, by definition, it will go through the focus. So let's draw using scale that this ray goes through the focus. So this is the second rule of our ray diagrams. So you can mark, it's very important to mark these arrows to represent how the rays are coming or going. All right. Now the third rule is a ray passing through F1. What happens to the ray passing through F1? So in convex lens, we know that this is our F1. So so you can easily predict if a ray is going to pass through the F1, then it does not matter what angle it enters. But if the ray passes through the F1, then it will exit parallel. It will exit parallel to the principal axis. So let's draw that. It will exit parallel to the principal axis. So let me erase this. Yeah, okay. So here is a ray. Any ray coming through the focus exits parallel to the principal axis. Now this is not very difficult because to understand, because by principle of reversibility, if I keep a mirror or something over here, this ray would exactly trace back the same path. So this is the same thing. We tell that differently. If a ray comes through the F1, it exits parallel. So these are the three rules for convex lens. Now let's look at a concave lens. Now let's do the preparation for the concave lens exactly the same way as we did for convex. So here as well we mark our points F and 2F. You may be wondering why we are marking this point 2F. Now this is a very special point, and you will get the significance of this in the following videos. Alright, so let's then finish by drawing the concave lens. That's something you can draw approximately. You can draw approximately two ends and try to draw the curved surface. So this makes our concave lens, so far from perfect, but that's fine. So let's now look at the rules for concave lens. So for concave lens, a ray which is entering parallel. So that's the first one. Let's see what happens to the ray entering, the first one would be the ray passing through the optical center. So let's get the first one as a ray. It can go at any angle, that doesn't matter. As long as it's going through the optical center, this ray should go undeviated. So let's just draw a straight line, and that is our first rule. The ray going through the optical center, which is O. I'm sorry, I haven't marked it here. O. It goes undeviated. The rule number 2 is a ray parallel to principal axis. So let's get this ray parallel to principal axis. So here it is, a ray parallel to the principal axis. Now this would pass through the focus. So let's position the scale such that it passes through the focus. Here it virtually passes through the focus. It doesn't really go through the focus. The ray would go like this, as you have seen in the previous video, but we extend this line and this connects to the focus. So this is the second rule. It'll deviate such that if you extend it backward, it'll connect the focus. Now the third rule is the ray passing through F1. So F1 is on the right side. So if there is a ray that's passing through F1, so let's construct a ray, any ray that passes through the F1. So the ray comes, let's say, like this. Then it would go parallel to the principal axis. It would go parallel to the principal axis. So let's draw this a parallel line, and that's it. There we are done with this. So this is pretty much same as the first rule or second rule, because if I would keep a mirror over here, then this ray would actually go backward, exactly the same path. So this is a ray coming passing through the focus, it goes parallel. So this is same as the third rule. So I hope you were able to follow these 3 rules, and these are the, you have seen these in action in the previous videos. You have seen the rays trace these paths in the previous video. Probably you haven't seen this one, but this one is something that you can imagine is a special case of this. So in the next video, we're going to use these rules to construct our ray diagrams for different scenarios. See you until then. Ciao. Bye.